Hello, 7th graders, and welcome to lesson 3.5 on dividing rational numbers. When we're dividing rational numbers, it's important to remember that there could be positives and negatives. So, some key notes here. If you have a positive divided by a positive, your answer will be positive. If you have a positive divided by a negative, your answer will be negative. If you have a negative divided by a positive, the quotient will be negative. And a negative divided by a negative, the quotient will be positive. That is an important thing you should write in your notes. That's going to be our key. All right, so example 1, dividing rational numbers. A diver needs to descend to a depth of 100 feet below sea level. She wants to do it in 5 equal descents. How far should she travel in each descent? To solve this problem, we're going to set up the division problem. Negative 100 divided by what equals 5. She wants to make 5 equal descents, so we know there's going to be 5 equal groups. We're starting with negative 100 because it's a depth of 100 feet below sea level, so we're representing that with a negative. All right, so we're going to rewrite that to think what number times 5 equals negative 100. So this is 5 times what equals negative 100. Remember the rules for integer multiplication, which are going to be the opposite of that chart that we wrote at the top. You also should have written that chart in 3.4. So if the product is negative, we know one of the factors must be negative. Since 5 is positive, the unknown factor must be negative. All right, so we know 5 times 20 equals 100. So using the rules for integer multiplication, we can say that 5 times negative 20 equals negative 100. So the diver should descend negative 20 feet in each descent. They should go down 20 feet in each descent. Okay, so let's reflect on this a little bit. What do you notice about the quotient of two rational numbers with different signs? Well, a positive times a negative is a negative. So we can write that down. Positive times a negative is a negative. So when we have a quotient, when we're dealing with division, if I have a positive divided by a negative, our answer will be negative. Or if I have a negative divided by a positive, our answer will be negative. If there's different signs, we're going to have a negative answer. What do we notice about the quotient of two rational numbers with the same sign? It doesn't matter if both signs are positive or both are negative. Just like we talked about in the chart, positive divided by a positive will have a positive answer, and a negative divided by a negative will have a negative answer. So if it's the same sign, the answer will be positive. Negative divided by a negative is positive. So here's that chart that we just wrote on the last page. A positive divided by a negative is negative. Negative positive is negative. So these are the different signs. When there's a different sign, your quotient, your answer will be negative. When they're the same signs, your answer will be positive. P and Q are just variables representing the numbers we would use. Okay, so next example, placement of negative signs in quotients. Quotients can have negative signs in different places. So notice, like if we had the fraction 12/4, I can put the negative sign on the 12 or on the 4, but if there's one negative sign, it's just going to be a negative number. So our solution, our quotient, would also be negative. Let's test this out to make sure we get the same answer. 12 divided by negative 4. That fits the positive divided by a negative. I know 12 divided by 4 is 3. My answer is going to be negative 3. Right, negative 12 divided by 4 is going to be a negative divided by a positive. That's going to fit that second row, which is also going to be negative 3. And if I have negative 12/4, that's going to be negative 3 or negative 3 over 1, which is still negative 3. So we get the same answer no matter where the negative sign is. The placement of one negative sign will not affect the quotient. All right, so let's look at some non-integer rational numbers now. Over 5 months, Carlos wrote 5 checks for the total of $323.75 to pay for his cable TV service. His cable bill is the same amount each month. What was the change in Carlos's bank account each month to pay for the cable bill? So this is basically just asking what one bill is. He wrote 5 checks that total $323.75. They were all equal, so we want to know what one check was worth. And because it's technically asking for the change in his bank account, that's going to be a negative change because when you write a check, it takes money out of the account. So the total is negative 323.75 divided by 5. So again, step 1 says we're using a negative number to represent the withdrawal from his account each month. That's because it's a check. It's a negative change. Now we're going to find the quotient. And you can do this 2 ways. You could set up a number line and count 5 subtractions from 0 because division is just repeated subtraction. Or you could actually use long division, which is how I'm going to set it up. So remember when we set up long division, we have the dividend, the number we're starting with, under the division bar, and then the divisor goes over here, so we're dividing by 5, and then we start at the left and move to the right. So 5 does not go into 3, however 5 does go into 32. 5 goes into 30 by 6. I have 2 left over, drop the 3. 5 goes into 20 by 4. I have 3 left over, drop the 7. 5 goes into 35 by 7. There's 2 left over, and drop the 5. 5 goes into 25 by 5. And the decimal goes straight up. So my answer is 64.75. This was a negative 323, so that's going to be a negative answer. Let's see if we got it right. And it matches, negative $64.75. Carlos withdrew $64.75 each month to pay for his cable TV. All right, so the next example, wow, now I have a fraction divided by a fraction. Let's set these up next to each other because it's easier to see division when we have it next to each other. So 7/10 divided by negative 1/5. Remember when we divide fractions, we change the division sign to multiplication, and then we flip the second fraction to its reciprocal. So this is going to be equal to 7/10 times 5 over negative 1. And then when I multiply fractions, I just multiply straight across. So 7 times 5 is 35. 10 times negative 1 is negative 10. And now let's simplify this to be negative 3 1/2. If you want to write 3.5, that works. So the steps that they walk us through, the first one is determine the sign. Because there's one negative in the original problem, there's going to be a negative quotient. If you're dividing with numbers of different signs, the quotient will be negative. The signs are different. Write the complex fraction. So we started with this. We have that right up there. And then we rewrote it as multiplication. We have that right here. And then our answer is going to be negative 35 over 10, which we can simplify to negative 7/2 or negative 3.5. All right, pause the video, try numbers 5 and 6 on your own. Check back to see if you got it right. All right, there you go. There are your answers, negative 0.7. And then number 6, we have a negative divided by a negative, so our answer will be positive 35/48. All right, your homework today is to do numbers 1 through 11 odd.